Welcome to data science class again, and in this class we will be looking at linear regression. Hi, I'm Vivin Arana. So let's start with linear regression. Now what will we be learning in this particular class? We will be looking at how to calculate a simple linear regression step by step. We'll see perform how to do calculations using a spreadsheet. So we'll take some data set, sample data set, which I'll just create, and then we'll see how to calculate it if we were a machine, or how does it do in the background. Next, predict on new data using a model. So we'll create a model and then try to predict the values for it. And then finally implement linear regression on a real world data set. So for this real world data set, I'm going to go to a vehicle data set from Kaggle has a vehicle data set from Car-Deco. This is the URL for this. I'm going to provide this in the details below, but you can go ahead and download this data set. I've already downloaded it. It looks more or like this, which has car name, year, selling price, present price, kilometers driven, fuel type, seller type, transmission, and owner. So what we will try to predict will be more on what is the price of the present price of the vehicle based on its selling price or kilometers per driven on the car. So that's what we'll try to predict in this example. We'll do this afterwards, but first we will have to understand how linear regression works. So I'm going to keep a document ready to where we will take a data set, create a data set, and do it on our own. So to start with, let's start with a simple linear regression problem. So what is a simple linear regression? When we have a single input attribute and we want to use linear regression, this is called a single linear regression. Whereas in our previous case, we saw that if you want to guess the present price, predict the present price based on the selling price, that's single linear regression, because you're doing output based on one single. If there is multiple, let's say if you have multiple inputs, selling price, kilometers driven, fuel type, year, so a bunch of these options, the process for linear regression is different and simpler in the simple linear regression, whereas multiple linear regression is a little bit more complicated. We will look at an example for a simple linear regression. In this section, we are going to create a simple linear regression model from our training data, then make predictions for our training data to get an idea of how well the model learned and the relationship in the data. So with simple linear regression, we want to model our data something like, I'm going to say y equal to b0 plus b1 multiplied by x. In this case, x is our input, y is the predicted output, or y is the output that we're going to provide in the start. But what are b and b0 and b? So this is an equation of a line where y is the output variable we want to predict and x is the input variable we know, and b0 and b1 are coefficients that we need to estimate that move in the line in the line around. It can be different values because the value of x and y will determine these values too. So technically bo is called the intercept because it determines where the line intercepts the y-axis. In machine learning, we can call this the bias because it is added to offset all predictions that we make. The b1, on the other hand, is called the slope because it defines the slope of the line, or how x translates into y value before we add our bias. So usually let me just create a quick data set so to show you how it looks like on a graph, so it makes more sense. So I'm going to give some random values, 4, 5, 7, 6. That's good enough for this test. And for y values, I'll say 1, 3, 3, 3 again, 4, 3 again, 4. So some random values here. Now I want to calculate, this is what I want to calculate. If I want to draw this graph or put it in a chart, I can just do insert these values into a chart, and I want to do a scatter chart, and it looks like this. So if you see, x-axis has x, y-axis has y, and the line, if you see the linear regression line, will be more like going from here going all the way up here. So something like this will be the best linear regression, because what you want to figure out is where is the closest that all these points intersect. And for that, b0 and b1, as I said, b0 is the bias, b1 will be the slope of the particular, so b0 is the bias, b1 will be the slope of this particular line. So that's what we will be trying to figure out. The goal is to find best estimates for a coefficient, which is b0 and b1, in predicting y from x. So simple regression is great because rather than having to search for values by trial and error or calculate them analytically using more advanced linear algebra, we can estimate them directly from our data. So we can start off by estimating the value of b1 as, so let's see, there's formulas for this, don't remember exactly, but I'll try to write it down. So it's sum of xi, which is xi is 0, 1, 2, 3, 4, so 1, 2, 3, 4 values of these, minus mean of x, where x is the average of all the x's together. And that so that's the first parameter, multiply by y of I minus mean of y, divide by sum of xi, it's not one, xi minus mean of x square of 2, that's the value. So there's numerator, which is this above, divide by the sum of xi mean of x squared root. So we'll try to figure out all these values from here. We can calculate bo and b1 once we have b1, bo can be calculated easily by using the formula mean of y minus b1, which we'll get it from the above formula, mean of x. Okay, so that's how we can get bo. So estimating the slope, which is b1, let's start with the top part of the equation, which is the numerator side of it. So let's see how we can get that. So first I'm gonna try to get the values for x. So let's say x, and then I'll copy all the values of x under this here, and then let's say what is mean of x. So in this case, since I want the mean of x, that will be equal to, can say average all these values, and I get that. So it's 4, so I'm going to use 4 for all of them. The reason I'm writing this here is because in the next one I'm going to calculate x minus, so x of I, this particular formula here, x of I minus mean of, so I'm going to say x, just write it that way, x of I minus mean of x. So let's get going, equal to this minus this. So minus 3, 1 minus 4 is minus 3. Similarly, I can just drag and that thing. So I get this particular value, xi minus mean of x, for all these values here. Next, let's do the same thing for y. I'm going to go ahead and do this very quickly. Same thing, I want mean of y and yi minus mean of y. How did I find mean? I said equal to average, do it to first, average of this entire set, get 3 is the average. So I'm going to use the same thing because I'll need it to negate here, equal to this minus this. I'm going to go ahead, pull it down. So values for that. So I have calculated this xi and yi mean. What I need to do next is I want to multiply both those values. So this xi of mean of x, yi mean of x. So I'm going to just copy this from here so that we have the reference, equal to this multiply by this. I have this 6 value here. So similarly now I can go back here and pull this down 7 times and make sure 1 2 3 4 5 6 7 1 2 3 5 6 7. The last one doesn't have a data, so that's why it's putting 0, because it's taking the next value here. So 3 multiplied by 6, and all 3 are 0, so it's going to be 0. 1 times 1, 3 times 0 is 0, and 2 times 1 is 2. So that's what I get for this thing. Now I will need the sum of the entire thing. So I say equal to, can just say sum, again, sum of all these values, and that comes to be 9. So I'm going to make it colored a little bit. So I got the numerator value here. Now what I do next is I want the bottom part of it. So I'm going to go ahead and say x minus mean of, so I need x minus mean of x, so that I already have the values. If you see here, I have those values here, so I'm going to copy these, paste it here. It's not going to show up properly. Let's say minus 3, minus 1, minus 2, 0, 1, 3 and 2. So that's my values. Now if I want square of those, one way of doing it is multiply by this again, and can just drag this, and I have the values available here. Now the bottom part is sum of the entire thing, so I'm gonna get equal to sum of this entire thing. There you go. So I have 28 as the sum. I'm gonna mark that. Now once I do that, I need to divide these two values, which is 9 divided by 28, so that I get 0.321. so that's the value of our B1 here. So that's how you calculate B1. So I'm going to say B1, that's the value of B1. I'm going to mark it with, let's say, green. Now how do I calculate B0? If you see here, this is how you get B0. So I'm going to copy that here, B0. Now to calculate B0, I have mean of y. Do I have mean of y anywhere? Right here, 3. Mean of x, 4. So this says 3 equal to 3 minus B1 is 0.32 multiply by mean of x was 4. So my value is 1.72 for B0. B0. There you go. So that's the value of my B0. That's the value of B1. Now I have both these values. Now let's see how we can make predictions with this. And if you remember the formula here, this is how you can make predictions with this value. So you can just put here these values. Now if I want to do predictions, let's say x, and this is prediction of y. Do we have x values from before? Yes, I do. I'm going to copy and paste them here. And here I'm going to say actual y, which we have values here. I'm going to take these and put them here. So now how do I predict the value of y? Predict the value of y is equal to B0, which is this, plus B1, B0 plus B1 multiply by x. So that's how I get the predicted y value. Now I can drag this down, and I'll have predicted value of A61, which is this one. No, that doesn't, because it took the next one. So I'm going to do 0. This one too, 60. It just went to the next line since I pulled it down. Same thing, 60, 60, and 60 for this guy too. So these are my, they don't look right now because A60, which is B0, plus C56, which is this one. So this has to be again C55 for all of them. 55, C55, C55, C55 and C55. Change this one, 55, and these are my predicted values based on the B0 and B1 that we have. Now if you want to plot a graph based on these, let's go and create a scatter graph that we did something similar to before. So if you see, it's a straight line. This is where the line crosses. Now if you want to make a line based on all three values, what I can do is I can just go ahead and say insert a scatter graph, and now you'll see here, make it a little darker so you can see. So the original values are in orange, whereas the predicted line or the regression line is right here in a straight line, and that's our predicted value. Now so if you see here, we have this line where this point is particularly perfect, but most of them have some error. Now how do you estimate this error? We can calculate an error for our predictions called something called as root mean square error, or also called as RMSE. So RMSE looks more like, the formula is square root of sum of pi predicted index minus yi root square of 2 and divide by n. So that's the formula for this thing, where square root is square root of function, so you probably know about square roots. P is the predicted value and y is the actual value. I is the index for the specific instance that we have. N is the number of predictions that we have, which is 7 in this case, because we can calculate the error across all the predicted values. First we must calculate the difference between each model prediction and the actual y values. So to do that, let's go ahead and write them down. So we have the predicted y values here, we have y values here. Now for the error, what I need to do is equal to, I need to do is A90, so this value, or so this value minus this value. That's my that's my error in prediction. So equal to this, this minus this. So I can just pull this down, have the values out there. Let me look at them. So they look fine. So this is the prediction value. So if you see this one where the orange and the blue line are intersecting is very close to 0, but that means the prediction was perfect, whereas this one has a high wrong prediction because of course 1 and 2.04. Now square of this, so we did the first part, which is pi yi. Next, now square of that is, because I have to do pi yi square of that, so equal to this multiply by this. I can just pull this down and that will give me square of the entire thing. Now sum of the value of this squared. Now if I want to get the sum of that, I can say sum of all these values, and that is my sum of the entire value. Now to do the square root, or first I have to divide by n, sum divided by n. So we have 7 values, so this is equal to this divide by n is 7. Say this is that value, which is sum divided by, now square root. So what you do is equal to, now there's a function square root of this value, and that's our RMSE, or something that is called as root mean squared error. So the less this is, perfect your predictions will be. So right now it's 0.66, so it's a little off, but it's pretty good for this. The best fit line that you can create for this predicting these values. Each prediction is on an average wrong by about 0.66626 units. So that's how you can calculate this RMSE. Next, now let's go to the So this is how I mean, it's pretty simple if you try it once, but you have to do it only once at least, so you understand how linear regression works. So next thing, we'll see how easy it is to do it in Python. The reason I went through this is you have to understand how they calculate all this, or how we used to programmatically calculate it before, and now it's made easier for us using all the different libraries that are available. So if you've already downloaded the data from here, I'm going to go to my Jupyter notebook, and if you see, my file is here called as car.csv. I'm going to start a new Python 3 project in this. So if you have gone through all the videos before, if not, you might miss out on some of the things, but what I'm going to do is I'm going to start importing pandas as PD. That's the first step. Next, I want my car data, so I'm going to say car data equal to PD dot read underscore CSV, and we've done this before. If you are missing out on something, you can go back and refer that. So I have my car data inside here. I can always look at my car data completely, or if I just want the head part, only the top 5, can look at the head 5. So you see, car name, you're selling, everything is available in this particular machine. Now what we are trying to predict is sometimes called as dependent variable. In our case, we want a dependent variable to be present y, which is y in this case. I can say car data, I'm gonna put that inside a array of present data. So I have my y data available here. Oops, sorry, present price, and I have present price available here. Next thing I want to do is my x value. Now in this case, I'm going to say car data, and the thing that I want to use is selling price. So just simple linear regression. Now we don't want to do the entire linear regression, so there's a library available, sklearn, that's what we'll use. Inside that we have linear model, import linear regression. Hope it worked. Let's see. Perfect. Now next thing that I want also to import is for our training and testing. So what will happen is we will take these data that we have, which is, let's say, car data dot shape. If you see, I have 300 rows of data inside here. What I want to do is I want to take this 301 and kind of use 30% of the data for testing, whereas 70% in training. So when you do machine learning, what you do is, or supervised machine learning, you give maximum amount of data, as much as you want, sometimes 70%, sometimes 80%, to train your model. And once it's trained, you test it with the rest of the data, 30% or 20%, whatever is left. And so this allows the computer or the machine to understand what you're providing with label and values, and then it also allows to test based on the testing data if it predicted the right value or not, just by cross-referencing. So that's how it works. So I'm going to use for that sklearn has another item inside here, model selection. So this will do model selection for me. Import train test split. So when we give it data, it will use different models to find the best algorithm to give you predictions going forward. So that's what this is used for. Now to test it, I can say train test split. Now I'm going to tell him how much data should I use. You use my x variables, x parameters, y parameters. This is what it takes. And the third one is test size. What amount of test size do you want to use? Out of your 100% of the data, do you want to use 0.2, which is 20%, or 30% of the data for trainings, which means the rest of the data will go to testing. So this will give me 4 different items: x train, which is training data with x, then it will give me x test testing data that are available. So since I said percent, is going to give me 210 rows, 91 rows, 30%, again y train and y test. So it's going to divide the data into that. So I'm going to put them, it's tuple, so I'm going to say x train, x test, y. I'm going to put them in different parameters. Make sure I use the y train comma y test equal to, so these are my parameters. So it's going to put all those values inside this. Training 70% of the data, testing 30%, 70 30. Similarly, if you do 2 here, it will 80 20 80 20. That's how it will define. What am I initialize my linear regression class? So I'm going to say linear regression, initialize this. Next, once I have that, I'm going to say lr dot fit. So try to find a model which will fit this training model and training y, x train and y train. This will copy paste all the values inside that, create my linear regression model. Now I want to xy pred equal to lr dot predict values for my testing parameters in x. And let me see, I did something wrong here. Predict is the function, predict for x test. So that's what that does. Next thing, let's look at y test dot head. So if you see some parameters here which will be my present values versus the values that I get for the testing data. I'm going to say y predicted value from, let's say, 0 to 5, the top ones. So if you see, the actual values for testing was 0.8, predicted was 0.74, 25.39, 35. So if you see, it's very close, not close enough, but it's very close to my testing data, whatever it predicted. So the 30% data that it took, it started predicting and it put in ypred. That's what I'm displaying here. And I'm testing with, I'm looking at the test data that I had just to compare how much off it was. And so if you want to kind of get the root, so this will give me a prediction information. But now if you want to see how much was the RMSE, the root mean square error, I can from sklearn metrics, I can import mean squared error. Okay, inside that I can say mean squared error with, it needs 2 parameters, testing and my prediction, and that's what we used right in our Excel. So right here, so here you saw what we did was we to look at the RMSE, what we did was we gave the y value was predicted value versus the predicted value versus the actual value. So that's what we need to give it to our function here, run it, and it's 0.0. So it's like perfect prediction. That's why it's saying why, because I put both the same values. Okay, change this to predictor, and there you go. 21% is the RMSE of this particular prediction algorithm. Now I can do it multiple one by saying that I also want in y, I want the, let's say, kilometers driven. So in my x, in my variable, I'm saying that predict this based on these 2 values. So I can just go ahead, run all these functions one more time, and now you'll see it's 40. So it's much higher. What if I just do based on kilometers per kilometers driven, and it's 145. So it's growing more and more. So depending on what the variables are or what you give, you can actually predict, get a better model out of it and predict values from this. So this is how linear regression works, and this is a class on, this is a particular code on that. You can try it on your own, follow this, and this will be available in GitHub.